All right. Welcome, everyone. It's a great pleasure for me to introduce my former team. I was working with these guys until last year, and we're here to talk about agriculture. In fact, digital tools in agriculture. So our main representative from the client here is Gabriela Rojas. Originally from Chile, now lives in our beloved Hauptstadt Berlin, and is the product director at Yara for what we're going to see today. She focuses on crop nutrition management and carbon footprint reduction, and has 15 years of experience building great teams and great products. Welcome, Gabi. Then we have Becker. He has already written PHP code while in kindergarten, and this led to a lifelong passion, which brought him to Karlsruhe, where he did a computer science degree. He's been a senior consultant, full-stack developer at TNG since 2019. And finally, we have Pfirrmann over there. He actually has a background in experimental solid-state physics, PhD, and he's been at TNG since 2022, where he has supported several customers as a full-stack developer and product advocate. So with this, we're very excited to hear what you've been building at Yara, and welcome. Get started.
Okay, yeah. Is this one right? Let me see how I do with this and this at the same time. Good. Thank you, everyone. Thank you for being here. Thank you for having us here. I'm Gabi, and together with Luca and Marco, we're going to walk you through some of the great challenges that we have been working on around agriculture, precision farming, and in particular, crop nutrition. So some of you might not have heard about Yara, but Yara is one of the biggest fertilizers company in the world, and we're focused on physical and digital products to help farmers on crop nutrition. So crop nutrition, farming, that actually doesn't sound that sexy or like that digital topic, right? However, we are working on some of the biggest challenges of our century: food security. Are we going to be able to feed the planet, the population, by 2050, for example? So by 2050, it's expected that the population is going to grow up to around 10 billion people, right? And for that, there are some researchers that said that we would need to grow the food from 2011 to 2050 in around 60%. And farmers have already a big challenges when it comes to growing food. Let me walk you a bit through the challenges that we have, and I promise I'm going to be short. First, economic uncertainty. So we know that interest rates are going up, meaning that financing is becoming more expensive. Labor costs are becoming more expensive. Also, the cost of inputs, so I'm talking about energy, fertilizers, animal feed, are becoming more expensive as well. Also, geoeconomical and crisis that you know that farmers don't have control about it. All that is making the inputs and outputs of farming to vary a lot and creating uncertainty. Second, climate change, right? I mean, a lot has been said already about climate change, but when I'm talking about climate change, I'm talking about precipitations, and I'm talking about temperatures, of course. So depending on the place that farmers are, that is impacting on the type of crops that can be growth, on the number of wildfires, on the range of insects, the range of weeds, diseases, right, that farmers are exposed to. Even hard conditions for people that are working on the field, some of them quite extreme, right? And third, adding into all this equation, environmental pressure, right? We know that farming is responsible for 11% of the greenhouse gases emissions in Europe. So farming is a big contributor when it comes to environmental problems, all right? That's the reason why in Europe we have all these laws that are trying to make agriculture more sustainable, which is great. However, that is putting even more pressures on farmers with all the issues that they already have on their practices, right? Good, so now that you know a bit more about the context on farmers and the challenges that they have, let me tell you a little bit of what we're doing at Yara. So at Yara, we're working on helping farmers on crop nutrition through precision agriculture. And precision agriculture lives in the intersection between the traditional agricultural knowledge, right, the new technologies, and data analytics. So some of examples of precision farmer technologies are satellite images, machinery automations, sensoring, and obviously big data analytics as well, right? And we know that farmers in North America and in Europe, they are very interested in these solutions. So they are either using already some of these solutions, or they're planning in the next 2 years to use some of these solutions. However, there are some friction when it comes to using these solutions. So one, uncertainty on the return over investment. Some of these solutions are quite expensive. And the second, user experience. Friction on setting these solutions, on creating the farms, creating the fields, and all that. That's the reason why at Yara we spend significant effort into really understanding farmers' pain points, understanding their journeys, and trying to create digital solutions that are easy to use, right? Our focus is on crop monitoring that you see on the left side of the screen. I'm going to explain a little bit what that is, and also crop nutrition optimization. On the left side of the screen, you see something like this product that is the end tester. So it's a device that has a LED, right? So with the light, you put it on the leaf, right? And that calculates the amount of chlorophyll that has on the leaf. That is a proxy for the amount of nitrogen that the plant has. And then, depending on how much yield you want to have with your crop, that is an input for calculating how much more nutrition or fertilizer you need to apply into your plants, right? So, I'm sorry. And this is VRA. I'm going to explain a little bit more VRA because it's going to be an example for throughout the presentation. VRA stands for variable rate application. So instead of applying the same amount of fertilizers through the entire field, you apply it in different levels in the different dots, let's say it, of the field. What is the problem that we're trying to solve here? We're trying to make more efficient application of fertilizer. So then the costs for the farmers are reduced. Also, the greenhouse gases emissions are reduced. And at the same time, we take care more of the health of the soil. And the way it's used today in AdFarm, which is our flagship digital product, is that you need to choose one of the satellite images that are for your field in AdFarm, with a biomass layer, hopefully one that doesn't have clouds, right? Because that's a problem, that's an actual problem, especially in Europe. So hopefully the most updated one without clouds. And then you need to set what is the type of fertilizer that you want to apply, and also what is the yield that you want to reach. And that gives you a map of what is the amount of fertilizer that you need to apply in each piece of your field, right? That sounds great, right? Great technology. However, we have some challenges on this. Let me quickly walk you through these challenges. So the first is friction on export and lack of integration between solutions. I'm not going to bore you with this graph, but essentially what I'm trying to say here is that people are using quite a bit VRA for creating this map. However, when it comes to actually export the map, is that what we're seeing that people are using it around 40 to 50% of export of the map. The reason why is this happening is because there is friction on the export. Today, what you need to do is download the file, put it on a pen drive, and then you need to upload it in the terminal of the machinery you're going to use to spread the fertilizer. And you need to do it by one, meaning that if you have, let's say, a farm with 50 fields, you need to do it 50 times. So definitely a lot of friction. And you might think, okay, well, the technologies nowadays, we can easily solve this, right? However, the challenge here, and it's a challenge in agriculture in general, is that there is a lack of integration between the different players in the market. And in some journeys for the farmers, there are involved different players, different vendors in it, that they don't talk to each other. So then when we're realizing about that, we start thinking more and more on how to improve the experience for the farmer, creating partnerships with some of these big vendors. That's the reason why last year we started an integration with John Deere to try to improve the journey of the farmer in VRA, right? So we're trying to put the best of the two worlds, right? From one side, Yara, that has cool knowledge on crop nutrition, right? We are leading knowledge on crop nutrition and digital products. And from the other side, we have John Deere, that is a big player in the machinery and machinery data. However, doing this integration had many interesting challenges, right? So now Marco is going to walk us a little bit through some of those technical challenges.
Yeah, thank you very much. So as Gabi said, in principle, we have a lot of frictions for farmers in these digital tools, and that's what our very own TNG AI assistant imagines currently the situation. We have a rather frustrated farmer sitting on a desk instead of being out on the field doing what they love and being out in nature. And the main or the biggest pain point in the beginning, the biggest hurdle to overcome is this: creating a digital representation of your farming operation in these tools. So in AdFarm, we provide the farmers with these satellite images and a drawing tool. So by clicking together a polygon of GPS coordinates, they can create a field boundary, give it a name, and set up the farming operation. Now, for demonstration purposes, I did this with this piece of land just behind our Unterföhring headquarters. And the beauty of it, you see it, the shape is quite irregular. So clicking through the whole process, mapping out this polygon thoroughly, this took me about, let's say, close to 5 minutes, giving it a cool name and whatever. And it's 5 minutes for me, who knows where to click, what to do. I've been working with this tool for over a year now. Let's say it may take a little bit more time for a farmer who does this for the first time. And farmers don't only have one field. When we're talking about a large-scale farming operation, it may be 200 fields. And 200 fields times 5 minutes, this doesn't scale. That's a big entry barrier to overcome when you want to start farmers using these digital tools. Now, I basically give away the solution here in the headline, data exchange made easy, because of course, AdFarm is not the only digital tool farmers would want to use in their journey. And exactly in the cooperation with John Deere, we try to improve this data exchange. And well, being here on a software developers conference, of course, the answer are APIs. And that's exactly what we're started with. So John Deere provides us with REST APIs. They have a scoped OAuth 2 authorization. And I put you here some of these endpoints. Basically, we can get the field boundaries, we get the field names, the farm names, and the relation which fields are in which farm. Now, in the next step, we present the user with a small selection screen where they can choose which fields to import. And then we put it in a queue, import it, and the whole journey from putting in your John Deere credentials to importing your farms and fields, this takes about 5 minutes. And with this, we drastically reduce the putting in the data. Then farmers can take these fields, create these VRA fertilization plans, and export them back to their John Deere Operations Center account. We added an upload via a post request with these APIs. And from there, they can transfer these plans to their tractors wirelessly through a John Deere internal system. As a bit of an additional point, we made this export not only for single VRAs, but added a bulk operation where you can put in many of these maps from a single farm and upload them with one single click, because that's what's ultimately about, reducing the number of clicks a user has to make. We keep the data in sync with webhooks that are provided by John Deere because we believe the data quality is best over there. Tractors have GPS devices mounted on top. They map out the fields when they drive over them. Data doesn't get any better than that. A funny side effect in improving data quality is also the fertilization information. When we export the fertilization plans, we are in control of the name of the fertilizer, of the brand name. So users don't have to enter them manually, and therefore we avoid mistakes or we improve data quality. Let's say it like that. Now, this rather easy journey for a user comes, of course, with a bit of a cost or work for us. We have to do some housekeeping. So we set up a sync database, Postgres-based, to keep track of the IDs of the entities. We start with what we call a synced farm. We have a farm on the John Deere side, we have a farm on the Yara side. Both of them have IDs, so we have to keep track of this. The same is for a synced field, so a synced farm can have multiple synced fields. Also here we have IDs on both sides and some timestamps, of course, to keep track of them. For the VRAs that we upload for the fertilizer plants, the same principle. One field can have many of these work plans, IDs on both sides. And this allows us to really control and keep track of the data flow incoming and outgoing. A very crucial part here is crop mapping. So in order to give a recommendation via the satellite images and calculate the chlorophyll content of the plant, we have to know what plant is grown there. And what the problem is, on the other side, John Deere doesn't really care about the crop plan. So they are a machine company, they focus on machines, and they just have crops as some sort of big table where you can choose from. For Yara, on the scientific side, the crops are input parameters for the growth algorithms, and it's the crop type that goes in there, and even the region where the crop is grown. So we have to map about the 200 different crop types that are on the John Deere side to the about 30 different crop types in Germany for which Yara has basically calculated the input parameters for the algorithms. And this has to be done manually. So agronomists have to look over, map it out, and then you have 200 or list of 200 entries on one side, 30 on the other side, times 16 German states, and you add France and UK, what we just did 2 weeks ago, and you end up with a mapping table of about 7,500 entries, which you have to basically create manually once, and hopefully then the user can import their fields. It says here the John Deere crop type, and in the Brandenburg region, we would map the white wheat to what we have, the winter wheat, with a certain protein content. Just to reduce the number of manual clicks, because imagine having to do this again manually for 200 fields. And that's fine. So we hope our farmer looks in the end like this. That's all fine and well, yeah? That's a great integration. Now, the challenge is AdFarm is not the only tool out there, and AdFarm isn't even the only Yara tool that exists. So to scale this even more in a broader Yara content, I would hand over again to Gabi to continue with our next challenge that we face.
Is this working? Yeah. Good. Let me walk you a little bit through the second challenge. As Marco mentioned, way too many apps out there, right? But that's even inside Yara, way too many apps. So essentially, there are a lot of solutions out there, and we know that farmers want to use these solutions. As I mentioned before, there's big friction into it, unclear return of investment, right? Complex setup, so we are trying to solve that. But at the same time, we know that these applications that are out there, they are very good for one or two functionalities. So then in order to complete some of these big journeys for farmers, they need to use at least one or two, sometimes even more applications or solutions, right? We know that farmers, they want to have, hopefully, a single app. And this is something that we have been studying for a while. Different farmers in different markets have already mentioned they don't want to have that many apps in their cell phones, for example, right? So then this concept of having everything in a single place is something that we start studying over and over. And then last year, we did more studies about a concept of product suites, essentially having everything on the same place. And we start studying how that would look like for desktop and also for mobile. And even for mobile, we start exploring having a single app, a sort of a super app, or having different apps, sort of like what Google does, right? Like they have Gmail and Calendar and Drive, like so the same sort of experience, but then data integration behind the scenes. And it was quite clear talking to farmers that actually they wanted the single app, right? The average farmer in Europe is 55 years old, so they might not necessarily have the same digital literacy that some of us have, right? So it needed to be simple. However, there is probably a trade-off between having everything on a single place and at the same time having that single place way too complex. So we start reviewing different options on how that single app could look like, right? So 9 or 10 months after, we managed to launch Yara Plus in Germany, in Belgium, and in Netherlands. Yara Plus is the all-in-one solution or platform for farmers around fertilization. And what it has in it is agronomical solutions. So for example, for arable, we have AdFarm. For grassland, we have GrassN, and we have other solutions. And in the same time, we have relevant content for farmers. So we have news, we have podcasts, events, and also a single place to access to customer support. That inside Yara, even inside Yara, for going into customer support for different applications, you needed to actually go to different places, right? With different experiences. That sounds simple, but behind the scenes, there were a lot of challenges that we needed to overcome. This is the first time that we were putting everything on a single place, even for us inside the same company, right? So just to give you a couple of examples, we needed to think on having a very strong design system in place, meaning a design system that then the different teams could use, so everything would look really the same. Also, stronger coordination on the teams. So these solutions were belonging to different teams. So then having them coordinated around the different decisions, that's actually hard to do. Even harder in a company that is moving, it's not a digital first company, it's moving into being more digital, right? And I think another example is clear governance. Who is the ultimate decision maker when it comes to what is gonna be inside this shell that now we're calling Yara Plus? Quite tough, so we actually overcome that challenge as well. But also there are technical challenges that we have been working around, and then Luca is gonna walk you through some of them. Oh, sorry, you have.
Yeah, I got this one, so yeah, I won't need the microphone. Thank you, Gabi, for the introduction. Hi, everybody. First off, what I would like to do is actually give you a real demo of what we're seeing over here. So if I manage to control Marco's laptop correctly, I hope everybody bears with me. Where's the cursor? Oh, we just need to find the cursor. Ah, there it is. All right, so we've got Yara Plus over here. So this is my account that I created the other day to basically show you what we're working with here, what are the challenges that are going on within Yara Plus itself. So this is the landing page we've just signed in. And we already face this sort of thing that Gabi already mentioned, where we have many different solutions being offered here to our customers that all need to come together, that all need to work with one set of data and operate based on that. So we're having GrassN, for instance, but we're also having the rewards program, which are sort of linked together, where they operate on the same farm, which is an entity that we're keeping in the background. So they need to share certain data. Then, as Gabi already also pointed out, we need to basically give the customer a consistent look and feel, right? They don't want to go to one application and be wondering, hey, this looks completely different. Did I just leave Yara for some reason? Or what's going on here? So all of these apps need to look similar-ish and need to give the customer basically a good experience there. And then we also have certain things that are shared across multiple applications. So you see, for some reason, everybody at Yara likes to call their farm Raza Creek. So I decided to go with that one as well. So I can select this one. And at this is not going to change all that much. But if I were to now go into our app switcher over here, or were to click there on GrassN, basically what is going to happen is I'm automatically have this farm selected. So I have multiple farms in my account because this is a large-scale operations in many cases, so keep in mind that the farmers that we're talking about here are not just farmers that have one field, that's not just your everyday farmer around the corner. We are talking about really big operations with a lot of fields, with a lot of hectares under management going on over there. And then we also have integrations to third-party APIs, for instance, that provide us with forecasts on our field, for instance, which are going to load right about now, where we can see things that are helping the farmer make better decisions on their fields and when to apply fertilizers and so on and so forth. So these are just some of the features that Yara Plus needs to bring, and where we then have to find technical answers for these challenges, basically to bring all of this into one package, to unify all of these apps and just to provide an awesome experience to our customers there. All right, and with that, the live demo is over. The other one, then we shall take this one. And let me just basically go one step ahead. So Marco's not the only one who can use our AI generation tool for images, so I managed to prompt this somehow together and then just put the Yara Plus logo inside of it. But I think this does somewhat illustrate, basically, we have a lot of different moving pieces that need to come together to make Yara Plus happen. And that is just really a plethora of APIs and services that need to be integrated. We have podcasts, we have the Yara CMS system, we have proprietary APIs at Yara which provide things like data about regions, about countries, about when you need to fertilize. We have some prediction APIs in-house, we have some third-party prediction APIs. There's a lot, and I have integrated many of them, and sort of bringing them all together and making them accessible in a coherent way is really challenging. And then also something that we would like to see from the backend is also having shared authentication. So we do not want to deal in every application, at least with authenticating the user. Authorization is a different story, because there you need to know what are you trying to access and what's the model. But authentication is something that you can really quite easily sort of do at the beginning and say, okay, these APIs, these calls require that, and then just process further from there. We have the various different front-end solutions, right, that we saw, right? We have GrassN, Tank Mix, we have the shop, we have loyalty, and actually many more to come. So we want to give those a shared look and feel, and we need to offer this shared functionality where a farm can be managed within multiple different applications. And then also something that Gabi already alluded to is we need to manage infrastructure. All of this needs to run somewhere, right? We just saw the domain, yaraplus.com. This needs to be operated somewhere. And as Gabi also said, Yara is not exactly a digital-first company, right? They started out making fertilizers, and then the digital aspects became more and more important. So we need to actually sort of punch way above our weight class there. And this is, of course, enabled through the support of AWS and other cloud providers, which give us just the possibility to just run CDNs nowadays, right? Even a company like Yara can now have a CDN, basically, or rely on services from CDNs. We are running Kubernetes clusters, we are running our user pools within AWS, and so on and so forth. So there's a lot going on to making all of this happen. So I'm going to start basically from what we're having right now, what we're running right now. Then going to take you a bit into the present, and then also at the end going to give you an outlook on the future. Just a fleet of microservices. I think at this point we are up to 13-ish, so one every month. It seems like, at least sort of considering that this has been going on for 12 months now. And they are managing different parts of the application. Yara is heavily relying on TypeScript and JavaScript applications, so Nest.js was the clear winner for us because it's just the most mature web server framework that there's out there. And then we also have Postgres as a relational database, because it's also just a beta-tested database that has been, oh God, I think the 80s or something, or maybe not the 80s, but still relational databases, at least the 80s, and Postgres maybe 90s or something. So that is where we are storing our data, but that's not all of it. I think one of the coolest tricks that we basically are using to making all of this happen is bringing all of this together into one GraphQL supergraph. So for those of you who have not worked with GraphQL, it's just basically an SDL where you can sort of query certain informations on a graph, so your data is structured that way. And normally, if you do it sort of, let's say the simple way, you just have one application, one graph, and that's it. But what is possible with Apollo Federation is basically stitching them all together and having them act as one. So you have multiple different services where you can then sort of separate the concerns. So you can have one service that does your users, you can have one service that does farms and fields, you can have one service that does another part of your applications like podcasts or news. So you don't need to put all of this in one place, but you can rather split them apart, which makes that easier sort of maintaining them and also distributing the load across multiple teams. And then also one thing that I actually wanted, okay, we actually have this graphic here, so you can sort of see requests come in. We have the gateway running over here, and then you have your services behind that, sort of how that works. And then lastly, also OpenSearch, Elasticsearch, obviously no longer really available on AWS for obvious reasons. But that is also something that we're doing, is trying to cache certain entities, certain pieces of information, just because these things don't change that often. Countries and regions, fortunately, don't change all that often, so it's fine to basically just storing them there and just leaving them lying around for, I don't know, 2 days, a month. Probably nobody would really notice. But what this also does is makes us more independent of third-party APIs, because mistakes happen. Mistakes happen at Yara, mistakes happen elsewhere, and APIs go down, and we do not want to leave our users stranded just because some other API is experiencing some maintenance window or downtime or whatever. And so this basically allows us to sort of make us a bit more independent there, and also allows us more random search patterns. So by just sort of pulling this data in, you can leverage then the query language that OpenSearch provides you. Another fun AI-generated image. I have no idea why these are coming out of the houses, but sure, why not? And that's about messaging at Yara Plus. Communication between microservices is key, right? They need to sort of interact with each other. Sometimes information needs to be passed on. Hey, this organization was deleted. Please also throw away related information. And you want to use deferrable tasks for certain things, right? Sometimes it's just not important that you do this right away. And that is where message brokers come in, or messaging solutions come in. And at Yara, we have decided against things like ActiveMQ, RabbitMQ, and all the other MQs that might be out there. But instead, we are running on a solution that is powered by AWS EventBridge and AWS SQS, which was so kindly developed by a colleague here in the room. And this is actually working very well for us. Especially cost-wise. So for those of you who don't know, we are running this currently at less than $1 per month in production. So just the free tier and everything makes it able for us to just have a full-fledged EventBridge or event service set up and to pass these things along. But then you also do not want to give up on sort of comfort features, right? So we have custom annotations that basically enable our developers to just easily access events and keep processing them when they come in. And lastly, also local stack for developer machines, basically to just see, hey, why isn't this working? Or to just sort of enable faster debugging processes there, because otherwise you would have to deploy this every time, or sort of integrate this with the actual deployed service of SQS and EventBridge. Right. And now to the front end. So we've seen basically how our backend is operating. And on the front end, we are using micro front ends with React. I feel still like most of the industry is still heavily leaning towards React, so does Yara. But we're also making all of these applications here happen by using Vite module federations. So these are not just always switching to a different application. We're not always refetching React and everything. But instead, what we're able to do is we just load the entry point basically to this application, and then everybody can sort of keep using the applications. The context stays the same, and this enables things like, oh, the farm switcher changed, so I have to do this and that now. And we can also offer shared functionality within Yara Plus. So if I were to create a farm, for instance, then that's still within Yara Plus, and other applications can use that. So we can share certain business functionality as well within the applications, and then make them accessible to the individual solutions. Providers give us shared context, so we have user management, right? Because there's just one user, you just log in with your Yara Plus account, and then you see everything that is associated with you. Or things like unit conversions. Units suck in a way, because we like to forget about them, and it seems so easy, right? You just say, oh, it's 5 or something. No, it's 5 kilograms. It's 5 kilograms per hectare or something like this. So we have to keep those in mind, and this basically just enables us just to download them once, and then we can convert on the front end. We also use the Apollo client, which enables us to do caching, for instance, which sometimes can be annoying. We've had some issues with caching in the past as well. Doesn't always work as flawlessly as you would like it to be, but still also gives our customers a much greater user experience, where they can basically just sort of see faster access. You can just basically fire the create an organization mutation to our backend, and then already add this one right away to the customer and sort of give them a faster experience there. And then lastly, what we also need, so Yara Plus is intended to be a solution for all of Europe, but also what we're having is feature flags, which we have implemented for our customers so that we can individually enable certain features or take them away, have a sort of soft launch there within certain countries. So here in Estonia, for instance, you might use TankMix at this point in time, but in the future, this might change as well when certain solutions go live there as well. Right. So this has been where we are at right now, but also Yara Plus is, as we've seen previously from Marco, is also about the future and also where we want to take this, and this is promised the last AI-generated graphic that we have for today, is we want to bridge the gap also even further between farming equipment, so be it tractors, be it fertilizers that you might attach to your tractor, and so on and so forth, and the knowledge that we have at Yara. So all of the knowledge that they have gathered about fertilizers and how to sort of raise crops as efficiently as possible, we want to bring that together. And I want to share a bit sort of on the future that we're planning. We're going to enter that phase probably in 4 weeks or so, where we want to have a dedicated service basically for integrating with external parties. So be it John Deere, be it any other manufacturer of equipment, and sort of act this as a single entry point for our network and sort of to leave our network again. It's going to translate then the webhooks into internal events for the event bridge messaging that we've seen earlier. And it's also going to allow us then to, since we're processing asynchronously, we can sort of give the customer real feedback, sort of, okay, we've just imported another field, we've just imported another one, and so on and so forth. So just like everybody knows this sort of spinner where it says, oh yeah, I'm processing, and you're wondering like, okay, you've been doing that for like 2 minutes. How long can it take? It's going to do the initial synchronization, so pulling in farms and fields, which we will keep as a source of truth on the other side. And also, we want to generify it in a way so that we can easily onboard the next partner to give our customers more integrations with third parties to reduce that friction so that they are more easily able to use the VRA, that they're using biomass and so on and so forth to bring this to them as fast as possible. But still, life is life, as Bojan likes to say, our developer colleague at Yara. And so sometimes you also have to just deal with partner-specific data, right? So UUIDs might not be used everywhere. Maybe they're just counting upwards, things like that. So just because you want to sort of generify things does not always work, unfortunately. And so you have to just deal with this somehow. You have to keep mapping data from A to B. And you also have to deal with things like constraints that might exist on one platform, but that might not exist on the other platform. So one of them might require you to at least have 3 characters for a field. The other one might not. They might be like, oh, you want to call your field B? Sure, why not? Or draw your field in the middle of the ocean. Doesn't make much sense, but if that's what you wanted, then you're free to do so. Right. So this is going to be our future. This is where we believe Yara Plus can have the biggest impact on our customers and help them sort of push further the furthest. And with that, I will hand over to one last slide for Gabi.
Yeah, thank you. Yeah, these are real images, by the way. Yeah, so very quickly, just to close, as you can see, we have made very good progress when it comes to putting together the traditional farming with new technologies and data analytics to try to provide value to the final customers, which are the farmers. However, we still have a big challenge ahead when it comes to really trying to make a lot of progress on food security, farmer sustainability, and farmers' prosperity, right? Those 3 are the ones that we need to try to improve as a whole. And it is clear, I think it becomes clear in the presentation, that this is not just one player challenge. It really requires the integration between the different players in the market, which is challenging. So we are focusing now on that, and also obviously we're relying on all these partnerships and help on different companies to help us on this challenge. So thank you very much, and pretty much looking forward to your question. Thank you.
Thank you very much for a very interesting update on the digital tools used in farming. Maybe I can start us off with a quick question here. I'm curious about this topic of fields, right? When we first hear of a field, we think, oh yeah, it's like this area out there somewhere that someone's drawn a polygon around. But actually fields change, right? Like what is a field? Like they change, you can subdivide them, they get bigger, they get smaller, tree grows. The things that you grow on a field change constantly. Then you have all these different ways of defining fields, like you can use satellite maps, right? We've seen Marco drawing polygons manually. You've said from John Deere you can import fields. There's like governmental registries out there for fields. So this is like a huge web of, field management that's going on. And I'm just curious if you could talk both from the conceptual and technical point of view, how are you dealing with fields in their ephemeral, ever-changing states? So I don't know if one of you wants to go first about that, but I'd like to hear a little bit more about that challenge.
I guess for us, working together with John Deere, it's quite easy. We take what the farmers actually drive across. So we really take the GPS data from the tractor. So if there's a tree growing and you can't drive or you have to drive around there, it gives it leaves a hole. It looks like a bit like a donut then, and we can just import this. Yeah? So it's part then of our field. So the surrounding area is then defined as the workable area, so to say, and we really heavily or in this point exclusively rely on the actual area that a farmer uses to drive on.
I can add on that, there are so many challenges when it comes to field, even thinking on how do you identify in a unique way a field. Now it's been developed this concept of global ID for fields, but it's not that much used so far still, right? So there's still a big challenge ahead on start using it, but even really understand, okay, this field is a unique field and I can identify it, or for example, you can go to some of these tools, as for example, AdFarm, and use and draw that field or use that field, but that doesn't, other user can use the same field, right? So then there is some duplication that needs to be solved as well. So a lot of challenges also on the conceptual side on identification of fields. Yes, there is a question there. I don't know who raised the hand, but I just saw him.
Maybe to add to this question, so I would have imagined that image recognition would be very helpful in identifying fields from satellite data image recognition. If that's an option to identify, because I would imagine with image recognition, it's probably easy, or not easy in quotation marks, to identify these fields. What do you think about it? Is this the correct assessment?
Please.
Yeah, so today there are a couple of ways of identifying fields. So one, depending on the region, there are, governments, for example, they have the data about the field. So they have it mapped and you can consume those, right? But in other places, it's satellite images, right? However, there are challenges on that. For example, there's images, or some maps might not be super updated, or some users, they claim that, hey, the map that is in there, actually now there is a road in between this field that you're showing me. So yes, I think there are different ways of identifying fields, but still there's no a standard way of doing it.
And also I think the workable area is another thing. It adds to the complexity. It's not the outer boundary, but there's also the workable area that a farmer really can use or does use.
Yes.
I think you have to...
Question back here first.
Okay.
Next time.
Thank you for this very interesting talk. You mentioned these integration challenges of all the different players. Is there some effort is there maybe a foundation of you plus John Deere and other companies to create open standards for exchanging data? Because if I imagine, I'm not a farmer, but I used to have neighbors who might be your customers. They don't only own John Deere or their competitor, but they own maybe the sprayer from one company, the tractor from a different company. Maybe they buy some fertilizers from Yara, but others or seeds from another company. So are you part of in the process of founding something that creates open standards for exchanging data?
Do you want to answer that?
I think let's say it has not been decided who is the actual standard. This is all just developing. Of course, there are companies or conglomerates that create these kind of standards also for these fertilizer recommendation maps. There are already some standards, but I think this is the companies are in the phase of realizing that they would need something like that.
Okay, we have another question up here.
Yeah, I just have a quick question. What does your customer base look like and your target customer? Is it basically only large-scale farming operations or also small-scale farms?
We are focused more on precision farming, so like it's our farmers that have large amount of fields and hectares, right? Because the small farmers, they would not really access to, for example, machinery, big machineries and all that. So that's the focus of the customers. Yeah.
But yet we also still have tools, thanks. But we also have solutions in the pipeline that are focusing also on other parts of the whole farming industry, right? This is a really big sector. Like many of us don't realize, maybe you just go to the supermarket and just buy stuff. But there are agronomists sort of working with it. There are consultants that are also consulting the farmers, and they are sort of also dealing with parts of the digital managing of a farm. So we're also having solutions in the works for those people as well.
You spoke quite at length about reducing the essentially initial investment and startup cost for farmers when it comes to using tools like this. And particularly for the process of adding farms and such, that seemed really great. But looking at the slide here, I see that you essentially have what seems like you've gone through manually and made a recording of the nitrogen level at 100 different locations for one field and have to then upload those manually. So my question is there any sort of form of automation for how to generate these maps? Because I guess you'd have to generate that map every single year.
No, the map you see here, in the top right-hand corner, that's a satellite image. So satellite really meaning an ESA mission which records near-infrared spectroscopy for chlorophyll. So this is basically auto-generated out of space. What Gabi shown was the handheld device. You're right, that requires manual interaction, but this also exists on a larger scale as a top mount on a tractor. When you drive across the field, you also do these spectroscopy measurements.
So, and you especially need this sort of solution then at times as well, right? Because as Guy was saying, clouds exist. They are a thing, and sometimes if you're in the UK or something, they might exist for a rather long time, and you still need accurate data, right? So then these sort of solutions might be more relevant if you're maybe in Spain or something, then you can rely on satellite imagery more.
And I guess it's more of a level system. So the more manual work you do, the more precise your data, of course, gets. If you only rely on satellite imagery, that's fine. If you go in the field and actually do a measurement, it will be a bit more precise. It's up to you how far you want to go.
No, behind you.
I have more a political question to you, Gabi. Do you really think that this will resolve the question of food security? Because already now we have, at least in the western part, more food than we actually eat. And it's more a distribution problem and not a food problem itself.
I think food security needs to go through optimization. There's no more land and there's no more water, right? So then the only variable that you have is optimization, right? So that means increasing the yield and helping farmers on the process of the farming, right? Which is what we are doing. But obviously, each player is doing a little piece of their pie on contribution. That's the reason I said really it's about having all the players working together with what they are best off on doing, right? But it's not solving, obviously, food security. It's a little piece of the whole equation.
Okay, one last question. All right, the gentleman in the middle here.
Thank you. You created a dedicated service for integrate third parties. So how complex is it to onboard additional parties like Trimble or now Akku joint venture or Climate View or stuff like that? So is it a huge difference to John Deere Ops Center? How much is the effort?
Well, I think that it depends, of course, a bit on the player. Currently, with John Deere, we're quite fortunate that they have established APIs that we can consume, because in this partnership, I guess John Deere is the bigger player. And for further partnerships, I guess there's both. So there's a team in Yara which creates our own APIs for someone to consume, or vice versa. But basically, even Trimble, for example, they provide similar APIs to what John Deere does, because, well, you have field boundaries and names probably on every platform. And so it's, for us, hopefully only a matter of changing the API endpoints, and the general concept adapted, like Lucas said, maybe a bit from our generic model to the specific player. But I believe that with the experience that we have from John Deere, the next integration won't take that long.
So we're also hoping to be able to do that based on the fact that we are also planning on limiting sort of what we're willing to integrate, right? Because if we were saying, oh, we want this and that and that, that's going to be way too complex. So what we're aiming for is really having a dedicated application that manages just the VRA part. So, and basically by artificially sort of limiting ourselves, we're also saying, okay, integrating further partners, they need to support farms, they need to support fields, they need to accept basically the VRA from us. That is already a rather small subset, but that also then makes it possible to sort of export this sort of thing and give this to our customers.
Last word from Gabi.
No, I just wanted to say that there is the aspect of the actual partnership itself, right? That is the B2B partnership. So we have a big team around sitting and prospecting and doing some trials. And then even for the John Deere integration, I mean, we started last year. We did a small proof of concept, and everybody gave thumbs up. And then we scaled it a little bit. And then we did a formal proof of concept with some farmers. And then, so it takes around a year and a half just to do this. So imagine if we want to do several of these, obviously that's a lot of investment.
Great. Thank you, Gabi, Luca, Marco, for a great presentation. Thank you also to the audience for some awesome questions. We'll have about a half an hour coffee break now. If you have any other questions, feel free to come up front. We'll still be here for a few minutes. Enjoy your Tech Day.